Yeah, thanks, Sergio, for the introduction. Now you can hear me, yeah? Perfect, yeah. So I'm going to talk about the custom CMOS image sensor for new space. And first of all, a few words about the company, if some of you don't know it. Okay, so we are what's called a fabless semiconductor company. So we design microelectronic circuit, but we don't own a foundry. So we use the one which is best optimized for the project. We were founded in 2017, where I founded with a partner. And our focus is to develop custom CMOS image sensor products. And we are very customer focused. I mean, developing a custom sensor can be an important investment for a company. So we want customers to get very good sensors, also with a controlled cost and in a controlled time. And we have customers worldwide which are satisfied and returning. That's probably the best recognition for us. And we are located in central Barcelona. Also, we can mention we are driven by innovation, and we have a seal of excellence recognized as an innovative SME, and we have just won an award from the EU for FTI project. So in terms of application, just a few words in general. So we don't do just space, we do also other things. I will show you some examples of sensor developed for other application, because I think they could be relevant also for the new space. So we'll talk about medicine, science, but of course also about sensor we are already developing for space. And also some sensors for more industrial and consumer application, which could be some interest also for example, with focus on low power, short development time, so which can be interesting for the new space. And also one more note is that we develop sensor for visible light, of course, but also for other types of light and also charged particles. You will see. So we do sensors for infrared and X-rays, and I will show you some example later. In general, as I said at the beginning, so we are driven by innovation. So because we develop new sensors, and we have to be cost efficient, because we want to be cost efficient, and we work with our customer from the beginning of from the onset of specifications, or sometimes can be still in a very draft way, and we work with our customer. So they could come to us with just a few lines of specification, and then we work with them to make them into a workable product. And then we do the design of the sensor, microelectronics design, using a state-of-art software. And we take care of the manufacturing. As I mentioned at the very beginning, we don't have a specific foundry where we make our sensors, but we partner with different foundries, and this, in some sense, gives us the flexibility of choosing the right foundry for the right for the project. We do the evaluation of the sensors, so we characterize it and we make it ready for volume production. And in this case, we manage the production with the foundry, so that the customer doesn't have to worry about learning about CMOS or other things, but we do this for them. And we can also do the packaging and the camera development, depending on the project. And in general, these are, so the developments, we go from, let's say, the initial idea to volume production, and we already have some sensors which are produced in large quantities. So an example is, for example, the first one, which is in this slide, is for dental imaging. But it's a kind of camera on a chip, and we have a family of sensors from 1.9 to 9.2 megapixel. And this has been in production for some years. It was our first project, and in basically from start to the project to start to the production, it was less than 1 year and a half. And as I mentioned before, we also developed sensor for charged particle detection, which could be of interest in space, for example, for dosimetry. And in the past, in one of my previous lives, I developed a miniaturized monitor for ESA, which was detecting charged particles. Just as another example of sensor, which is not for space, but probably bears an interest in this context, is a sensor we are now completing the development, is for consumer application, and artificial intelligence is a small pixel, 2.5 micron pixels, 2 megapixels, and it has low noise and low power. And this is a color sensor which has only a very simple digital interface which allows to control the sensors, change the parameters of which is used for working, and of course reading the data. And we're also doing sensors for aeronautics, but I cannot say much because of NDA issues. Now going towards sensor we are developing for space, but can be adapted also for the new space. Let's say we're developing for kind of old space, but as it was said by the first speaker, also the borderline between old and new space is probably fading a bit. So this is a sensor we are developing for Asian Space Agency, and it is a high-speed CIS for lightning detection. So it looks at the Earth from space and detect lightnings, and it has different technical characteristics. The main point is a fairly large sensor, 5 by 5 centimeter, 4 megapixel, and working at high speed, 340 frames per second in full frame mode. And again, is fully integrated, so it has a very simple digital interface, which simplifies also the development of the camera. So there are not many components in the camera. It's very simple. If one has to certify it, would simplify this. And also it is designed for radiation. It has radiation hardness for its space component. And this we are completing the development also in this case. And also for the European Space Agency, we are developing a hybrid sensor, which is targeting visible and near infrared detection with high quantum efficiency, over 70%. So in this case, it's a hybrid sensor. So we have a detector layer, as you can see in the picture, and then a ROIC, and we are so we developed this with other partners, including Alter Technology, and we are responsible in IMASENIC for the photodetector diode and also the pixel design for the sensor in this case, and also the hybridization with bonding. And the sensor has got also fairly low gain, low noise, and high full well. Now, maybe very briefly in the last few minutes, I will talk about some kind of new developments. One is a sensor for visible and whre. We are developing with some partners, and we are looking for European funding for second phase for developing a full-scale imager. There are some results. The interesting part about this detector is that one can have infrared and whre in the same sensor and just select one or the other band in an electrical way. And the last type of sensor I wanted to present is single photon avalanche detectors, which allow to detect timing by single photons and their arrival time in very high resolution. So they're used for Lidar. They start to be used for Lidar also in other applications like automotive or consumer. And the interesting thing about doing SPAD in CMOS is that they can be readily, well, the technology allows to integrate it in imaging arrays, so you can have large number of pixels, and each of them with independent, very well controlled timing. And there are different developments, different so performance. I won't go into the details, but one can optimize the performance or choose already the standard parts from the foundry, and we will integrate them in our sensor. And also nowadays, probably some of you know about the possibility of integrating several chips, one on top of each other, to make into what is basically a single chip, but made of different layers, where each layer is optimized in a different way. So you can have a sensing layer, then a signal processing layer, and then a high-speed interface. And there are different ways of building these type of sensors. So coming to the conclusion, so we produce CMOS in a sense with innovation, and also sensors which are reliable, can be put in space, and there are a lot of different technologies that can be applied. So in general, I would say, if you have an imaging project, please come to us, and we will look for the best solution for your project. And we are already developing sensors for space, and we can certainly be your partner of choice for the development of CIS for new space. And this concludes my talk. Thanks for your attention, and if there's any question.
Okay, thank you very much, Renato. Those of you who have questions, please, now's the moment. Any question for Renato? I have one, very simple.
Maybe I have a question.
Yeah, Rico?
Well, it's not quite technical, but it's market-oriented. In Europe and the CMOS imager company, which can make CMOS
Rico, could you start again? Because with some micro cuts, could you start again with your question?
Yeah, okay. Do you hear me now?
Yeah.
Do you hear me? Yeah. My question is not technical, it's more market-oriented. I was saying that worldwide, those in Europe, the domain of what you're doing as CMOS imager is quite dense. So, I mean, what are your differences with you, say, for example, with the E2B now, Teledyne, or with the Dutch, with the Belgian? There are quite a few companies which do this type of CMOS.
Yeah. I mean, one thing is that
what you offer extra? Yeah. Okay.
So
the question, Renato, is what you offer extra from your competence. What's the difference of your proposal?
Well, we are certainly. I mean, first of all, I mean, there are always new application image sensor, and there's a wide variety. So there are space for several companies, and certainly we have a very good specialty on very recognized for large sensor, high speed, and also low noise part. So sometimes we compete and we win the competition with companies like the ones you mentioned. So, there's some overlap. The space is quite wide, and I mean, as I showed in this slide, so there are a lot of different things. We know that also the companies you mentioned, they do some of these things more or less well. And it depends really often it depends on the application where we can, as I said, we win sometimes over Teledyne, DALSA, and or others I won't mention.
But it's quite impressive. I mean, I'm quite impressed from your presentation, and that since it's a rather new company, it's at 2017. So you're going a long way ahead there.
Yeah.
Congratulations.
Thank you.
Thank you, Enrico. We have another question from Juan Pastor from Indra. He says, I would like to know if IMASENIC has experience in defense applications, particularly on flying platforms.
So we do have experience in defense application. So we have with a project, well, we can't say much because these projects are always very well protected, but yeah. Okay. Yeah, also on flying platforms, objects, yeah. I can't say too much, but yeah, we work in defense, yeah.
Okay, nice. Then if Juan agrees, I can put you in contact to go deeper. Okay, thank you. Another question? No more? And thank you very much, Renato. Very, very interesting. A variety of sensors in a very short time since 4 years ago. I remember 4 years ago when we started talking about, and there is a lot of things that you have done in these years. Congratulations.
Thank you.